I hope my screen is visible.
Yes, it is.
Okay. Good morning, all of you. This is Soumya Pranjal, host for today's session, and today's session is all about microservices by Sanket Modi. About Sanket Modi, he works as associate manager at Accenture. He has explored AWS, Azure, and other clouds and cloud-related technologies like Kubernetes, Mesos, etc. He has vast experience of project management and client communication. For more details, you can go through this fifth IR speaker profile link of Sanket Modi. About Fifth IR, that stands for Fifth Industrial Revolution, we are the initiative by Multi-Cloud for You to help companies and technologies to openly share their learning and get opportunities worldwide through each other as well as through our partners worldwide. Here you can see how we are growing day by day. There are 10 upcoming events in the month of March, and we have completed 1074 stations and we have 360 uh, active speakers with Fifth IR portal. And you can see 8,498 certification courses are available on Fifth IR portal, and we have 25,854 members with us. Our relationship with Bata Global, Dell, Brilio, Tiger Analytics, Alibaba Cloud, Data Piper, Philips, Jira, and multiple small and medium companies. We also frequently engage evangelists and engineers from Microsoft and AWS. We are also an Alibaba Cloud Academy partner. So here you can see few samples of Alibaba Cloud certification courses. We can help you in building your knowledge, digital presence, and helping you in odd hours when you are looking for jobs through our community. You can get all of this with a single link, that is www.fifthir.com. For getting the certificate, you need to register at this event link and then click on claim certificate and provide all the required information, and then you will be asked for a code. Enter the code which will share at the end of the session for downloading the certificate, and for any further issues you can connect with us at multi-cloud for you, and we have our telegram channel, that is telegram.im/multicloud for you. Thank you so much. Now over to Sanket Modi.
Yeah, thank you, Soumya. So I'll quickly share my screen. Okay, is my screen visible?
Yes, it is.
Great. Okay, so hello everyone, greetings of the day. And as you know, this is a session all about microservices. So initially I was planning session on different things, coding, microservices deployment and all those things. But then we'll understand exactly why I drafted this particular session as all about microservices, because uh, I see that this session is getting delivered in 2023, and uh, we all have heard about microservices. What exactly is microservices, why they are required, and how to implement them actually. So we'll try to understand those aspects in this session. And the most beautiful part of this particular session will be we'll see practically how to utilize ChatGPT. Right, ChatGPT is already a buzzword nowadays, and everyone is trying to utilize ChatGPT and try to improve their productivity. So so at the end we will try to understand how can we utilize the AI platform ChatGPT to make our life much more productive. Apart from that, we'll definitely understand how to right from how to design microservice, how to initiate and perform communication between each microservices, what are the best practices of logging, deployment, security, and we'll also see some design patterns. I have included very few design patterns considering a 1 hour session, but yeah, we'll definitely see uh, what are different design patterns of microservices. Okay, so we'll quickly start the session. As you already know all about this, and just one more thing, what Soumya inform, I'm also author at Knowledge Junction, and over there also I have started the series Microservices. So whatever we will discuss over here, that's majorly an overview of each different concept. I am creating an article over there, in detail article for each concept. So if you think you have some more questions, you can definitely go there and check those articles. Okay, so we'll quickly start. So in order to understand what exactly is uh, microservices and why we need them, first we'll need to understand what was there before microservices, right? So there are multiple different architecture available. Okay, we can consider all those architecture as a monolithic architecture. Okay, mono means single. So in early days, all the modules or all the functions of a particular project was created using a single or was coded in a single platform. Okay, so for this complete presentation, I'm going to use a existing microservices based project, that is Google's Google Cloud Platform Microservices demo. This is very nice project and example of microservices and how to implement them. So I'll quickly reuse this particular project to show you how to design and what to design using microservices and what to expect. Okay. So considering this particular okay, yeah, so considering this particular project, if we try to imagine that if this particular project was developed using uh, monolithic architecture, okay, all these modules, different modules of this project, you can see they have also created a nice architecture diagram over here. Yeah, over here. So all these are different microservices. Whatever you see over here are microservices. But if you consider it as a monolithic architecture, okay, all this will become a separate module of a single platform, online beauty. Okay, and if we try to consider it as a source control, it will be part of a single git repo. Earlier it was svc and other source control available, but if you consider git, then all these module will be part of a single git repository. So when we start a project in monolithic architecture, it's really very small, but as and when it grows, the code base becomes huge, and there is literally lakhs of lines of code, and it becomes really very difficult to manage. The advantage of monolithic architecture was technology stack. So for example, if you think that this platform I want to develop in Java, then all these module will be designed in only single programming language, that is Java. Okay, they will be still be separate modules, and they will be calling each other's method to perform tasks, but everything will be in Java. Okay, the primary problem what people faced using this monolithic architecture was when it used to get deployed. Okay, suppose this particular boutique, or imagine Amazon as a a single product, and it is available to everyone, and if complete Amazon product is deployed on single virtual machine, okay, and if user base increases, what will happen? We'll have to add another virtual machine and deploy that particular product over there and create a load balancer on top of it in order to manage the complete workload. So for example, if a single virtual machine is costing $50 per hour, our cost will directly increase from 50 to directly 100. It will double, and as and when scaling will happen, the cost will increase and it will be huge. And this particular calculation was done on overall load. So for example, if we have multiple orders or multiple requests in catalog, we'll still need to scale complete application as a separate VM. So that was a huge limitation at that time, and in order to overcome this particular the limitation, people came up with a microservices. Okay, so you see most of these services are still here when we talk about microservices, but each of this service became a single project. Okay, so for example, consider project of 1 lakh line of code, you divide that particular project into 10,000 line of code as a 10 project and give it to 10 teams. It will become much more manageable, much more easier, okay, to develop. Okay, so this exactly is microservices. But the primary question is, when we divide this particular single project into multiple small project, the huge question is how they will communicate. Okay, so earlier also there was HTTP protocol, right? Whatever internet related operations we used to do, we used to access any website, YouTube or any other website, we used to do it with HTTP. So over here in initial design of microservices, they utilize the same protocol to talk to each other applications. It has improved a lot significantly. Okay, so we'll see that, but initially that was the design, that each microservice will talk to each other using HTTP protocol. But much bigger advantage was each of this application was a single project itself. Okay, so if we drill down a little bit more, each project is a independent project. The complete design is decentralized, so that whatever if some new person is coming in catalog as a development engineer, he or she doesn't need to bother about any other microservices. So that is another example or another advantage of microservices. Okay, API integration is using HTTP, and we'll see all these advantages as and when we move ahead in our slides. Okay, so we'll quickly move ahead and we'll see why we need to learn and understand microservices, right? So if you observe articles and posts on LinkedIn or some news, tech news, you'll observe this microservice word very much frequently. Okay, and just a few days ago, just 2 3 days ago, when I was designing this particular slide, I actually searched that how many jobs in Australia are available where microservice is required. So I found more than 2000 jobs are available where they want microservice as a skill. You should have that particular skill in order to apply for that job. So a lot of jobs are there. And if you see successful implementation of companies who have already implemented a great example of microservices, Netflix is one of the best example of microservices. They started moving to microservices a long time ago, and they already moved. Okay, then there is Amazon. Amazon is also one of the good example of microservices. Uber is there. So there are a lot of platforms who have successfully implemented microservices, but there are a lot of platforms who actually failed in initial stage when they were moving to microservices. We'll observe all these things during this session. Okay, so I hope these things are clear, because microservices is a required skill nowadays. That's why we should be aware of the overall nomenclature of microservices. Okay, I will quickly move ahead. So for example, if you are designing a microservice of you, or you have a project, you want to start with it with microservice, or you want to migrate your existing project to microservice, then how will you start? So there is this best design available. Okay, it is business capability or business functionality. So you need to first identify business capabilities, what you are trying to migrate. So for example, we are talking about online shopping system. So over there we will have product catalog, we'll have inventory, we'll have order, and we'll have delivery, all on the left hand side. These are capabilities, business capabilities which we want. Okay, directly move them to your architecture, application architecture, and make them smaller microservices. They all will implement their services, and they will provide their services to each other, and this will immediately become your best microservice architecture, overall architecture. Then if we talk about product catalog, you can divide it furthermore. You can divide inventory as well, you can divide orders as well. All the microservice you can divide further, okay, as per their requirement. But when you're talking about overall architecture, overall design, you can start with this design. Okay, so this is the overall design, and yeah, we can quickly move ahead. Okay, so what I did was, I directly took this particular modules and make them over here as a small microservices. So if you observe closely, each microservice has their ability to choose programming platform and team. So for example, when I talk about the early days when we used to do a complete project in Java, we were using JSF and JSP and other technologies to make them compatible talking to each other. Now when we move to microservice, this particular language barrier is no longer there. We can design each microservices in different programming language because they are talking to each other using a common protocol, that is HTTP or any other protocol, but they are not calling them as a different module. They are talking to each other using a protocol. So that's one of the best advantage of using microservices. And if you really want to see the example, the as I told you, right, we are going to utilize this particular microservices demo from Google. So this particular project, cart service is designed using .NET, checkout service is designed using Go, currency is designed using Node, and email is designed using Python. And we can also check it over here. This is the complete project, right? And the complete source code of this project is in this SRC folder. Okay, and you can see this all services are there. Actually, hide controls. Okay, this is much better. Okay, so if I open this email service, okay, it is designed in Python. The complete code base is in Python. And if I move to add service, for example, add service is designed in it is using Gradle, so it is Java. Okay. Likewise, all the services are designed using different programming language platforms. Okay, but still they are talking to each other. Now you might have observed that it is microservices project and it is developed by Google. Okay, still they have all the services as part of a single repository, right? So that particular is again a function or feature. You can consider it as a feature, but you will find two different type of implementation when we talk about source control. Okay, some people prefer to keep their source code as a single repository, and you'll find ample of examples where source code or each project or each project is considered as a separate repository. Okay, in our code as well, when we started it was 15 repositories, and right now we have more than 200 microservices available, and each are in different repository and all the operations are different. Okay, so over here I have shown the example of Istio. So if I go to Istio is again another very nice project from CNCF. It is very famous, and if you see their repositories, Istio.io is when you actually install Istio in your cluster, you will have all the features available. But when you check their source code, Istio is written in Go, it is there. Istio.io is written in HTML, it is a different project. Istio community, Istio API, Istio proxy, client, all these things are there. These are different repositories, and they have more than 40, about 40 repositories there, right? So you can design your code accordingly. It is more preferred that you keep it in separate repositories, just to make sure you maintain it really very well. Because in case of this demo, if you see, they have used GitHub workflows in order to make this project a CI/CD compatible. They do this build and all. So if I open uh, this main.yaml, whenever I introduce any new project, I'll have to update this all steps. Basically, GitOps is another way to make your project in CI/CD, continuous integration and continuous delivery. Okay, so over here, they whenever there will be a push request, or merge to master request, they will have this particular workflow execution, and it has different steps. Okay, so as it is a single repository, they will have to make sure that any modification to this will impact the overall project, whereas in other cases it will be separate. Okay, so most of the time people prefer to keep it separate because it is manageable, it is easily manageable, all the operations. Okay, so we'll come back to the presentation. And not just this Istio, you can see if it is open. Yeah, Kubernetes is also there. Kubernetes is also a open source project, and also they have their modules written in different repositories. They have about 77 repositories, and each repository is written in different programming languages. It is also a microservice based project. Okay, so not wasting a lot of time over there, we'll quickly move on. So designing your code and source control, it's completely in your hand, but it will be better if you keep them as a separate repository. It will be manageable. Now, for example, I have this microservices implemented. Okay, how to make sure that my checkout is able to talk to my card service? Okay, so there are three ways of different ways they can talk to each other. uh, I hope everyone is aware of synchronous communication and asynchronous communication. Okay, so synchronous communication is when I am making call to any any API and expecting a response immediately. Okay, I'm waiting for it. For example, add this particular product to cart. Okay, I will wait. It's a small operation. I am sure that it's not going to take more than few seconds. Okay, seconds is also a long time. It's not going to take more than a second. Okay, but for example, if I am allowing user to upload a catalog as a Excel file in a particular format, it's going to take time. So I can make it as a asynchronous. I'll upload that particular file and then we'll wait the response in notification. So when there is a asynchronous communication, you have to implement, or it's better practice to implement a notification service as well, which will communicate the actual results. For example, if you provision a virtual machine on Azure, it won't ask you to wait on the same page till virtual machine gets provisioned. You'll get a notification on notification bar saying, yeah, okay, your request is accepted and your virtual machine provisioning is in progress. Okay, and once your virtual machine provisioning completes, you see a successful message over there in notification bar itself. Okay, so coming back to again to communication. So when you are making a communication, you can design your communication in these two ways: synchronous, asynchronous. And when synchronous, for synchronous, you have two options. Most famous, and a lot of people are using REST, but nowadays people prefer to use gRPC. GRPC internally uses HTTP too, but it is much more faster than REST. We can have a separate session on gRPC. It is very famous, and in this demo again, it is using gRPC. Okay, this microservices demo uses gRPC for communication. gRPC is just extension of RPC, remote procedure call protocol. Okay, but it is much more faster than HTTP. So people started using gRPC for their cluster. Okay, so just to explore, elaborate on what I just said, these all services, okay, when they will be deployed in a single cluster. Okay, so when they will make a communication to each other, it won't go outside the cluster. So internally they can utilize the gRPC protocol to make communication much more faster. Okay, so checkout making call to cart making call to currency, and all internal communication. Okay, so again to the slide, uh, you can have two types of communication, and synchronous, and if you want to implement asynchronous communication, you can utilize queues. There are ample of queues available. Okay, these are just few examples. RabbitMQ is very famous, and it's really very old, one of the oldest queue available as far as I know. Okay, and its performance is very nice. It's very fine tuned queue. You can utilize that for asynchronous communication. And the latest one, okay, if you search this keyword service mesh, Istio, the one which we saw just few minutes ago, it is one of the service mesh. So what service mesh does is it creates a proxy over your service. Okay, and it makes sure so that your particular service, your particular container is in always in a safe or secure environment. Whatever service, whatever request comes to your particular service, it is always secure. So Istio is one of the example, and these are different examples available. OpenShift and AWS app mesh, all these service mesh are available. Okay, we can utilize them to establish communication between two services or two containers. Okay, so uh, another point when you are designing a microservice, you always have a database, right? So this first one is just uh, taking your monolithic database to microservice, which is not advisable. The other option is you create a database for each service. Okay, it always depends. These two are practices widely followed. Okay, these are just random connections. Don't consider it as a practical example, but it is just showing that you can either have a shared database across few services, or you can have a database of each service. Okay, this is what I want to actually demonstrate over here. Most of the time you will observe that there are databases available for each service, as well as there are some databases which are shared, because they frequently want to talk to each other or pass message. Okay, so when there is asynchronous communication, you can use queue to pass the message, or you can use database as well. So you can update some entries in database, and the other party can pull database to get the latest update. So but messaging queue is a better way of communication. Okay, so we'll quickly move on. One of the most, so these all things what I'm discussing is from whatever I have experienced. Okay, so one of the crucial thing when designing microservice and your particular microservice is logging. In monolithic architecture, what used to happen is whatever input comes to your project, okay, it comes as a project, and the output is directly given to the user, and whatever happens is in this single source code. So whatever log you will find, it will be a single huge log or file, and you need to find your find your code log over there. But in case of microservices, we'll see this pattern in design pattern. You can design your microservices in a way that they are communicating. There is a channel, there is a chain of microservices calling to each other. Okay, we observe the same thing in earlier slide as well, right? That you have a microservice, you have one microservice. So for example, orders microservice, you've divided that particular microservice into smaller microservices, so they will be talking to each other. So when this message passing happens from microservice to microservice, it really becomes very difficult to find where exactly there is an issue in my code. So it is really very important that whatever request comes to your, that whatever entry point is there for your microservice, you assign a id to that particular request. You can call it a request id or correlation id or connection id. This id can be a common id which will be a reference point for all your logger. Okay, so for example, in this case your entry point is microservice 1. Okay, and last service getting called is microservice 6. So all the microservice which are making log entries will, I will keep that particular identifier in log, that this particular log line is representing this particular request. Okay, so that will help you to drill down any issue very easily and very quickly. Okay, so this is one of the best practice. Another best practice is you can introduce a event logger or event sourcing. Okay, this is becoming very famous now. For example, you are processing a order. Okay, so what you will do, all the major operations will go to a single database or a single service where it will be logged further. Okay, and for example, you are processing a order. Okay, so processing order will also introduce pricing and completing the payment. So both the service will provide the major logs for that particular order in that event logging service. Okay, so from that single service you will be able to identify that where exactly my uh, this order failed, which service was unable to process the order. Okay, and there are a lot of event loggers available. If you search, you will find ample of tools available. You can directly use them and finish your job. Okay, other all the best practices will be from monolithic architecture. You should not be or must not be logging any sensitive data. You should be mentioning each service name. So for example, whatever your microservice name is, you should be mentioning that it is for especially when you are using event logger, that this particular log came from this particular service. Request URI, timestamp, duration, and call stack whenever there is error. So these all are different best practices which are from monolith only. So you must be following that. Okay. So this is one thing, and uh, this is the most beautiful part of microservice. Okay, once you are done with your setup, these are different tools. Okay, you will see a lot of tools apart from these tools as well. Okay, so once you decide that you want to move to microservices, the one of the advantage is customer satisfaction. Why? Because earlier when they request you any feature, any new feature, okay, it may take a month, 2 month, 3 month, or 6 month cycle to deliver that particular feature. In case of microservices, this is a live example. In our project, we used to deliver each feature, each requested feature, or each developed feature, to be precise, to directly in a week. So, for example, I am coding something today. Okay, it will reach to our customer next week itself. Okay, and how is done? Once we push any code to Git, okay, it automatically executes some Jenkins builds or Go routines, and then whatever test cases are written. So one of the important thing while working on microservices is writing your unit test and integration test. Okay, so unit test plays a vital role for maintaining your microservice. So for example, you are working on microservice right now. Suppose someone else comes in tomorrow, okay, and makes any code change. Now that code change has to be compatible with when other services are calling to your microservice. Okay, so in order to make sure that the contract, it is basically called contract, your contract is not getting changed by anyone accidentally. Okay, in order to make sure that particular part, you have to write, or you must write unit tests and integration tests as part of your build cycles. Okay, I can show you, it is even implemented in the Google project we are referring. So we see over here, right, they are using Git. Oh, I can directly show you the actions. Okay, they have used Git actions. So if I open this you see a lot of failures. Okay, so if someone is making any code change, they have to make sure that the end product which is going to the customer at after 1 week is not breaking anywhere. And in order to make sure that particular part, you have to implement this continuous integration to your code. Okay, and once integration is done, you need to just deploy it on either Kubernetes, Mesos, or ample of, again, uh, OpenStack is there. Then there are ample of platforms available where you can directly push it. Okay, and nowadays people prefer to keep it on cloud, so you can directly provision Kubernetes cluster on Azure or AWS and directly push your code over there. So this is a complete deployment. This is a complete collaboration of microservice from the beginning to the end. Okay, so this plays a vital role while designing microservices. The next part is security. Security is very crucial part. Okay, and people use this term nowadays that our code is secure by design. Now, what does that mean actually? So your security is implemented at different layer of code. Okay, your your actual code which is executing as a container is secure by making sure that it is not logging any secrets. So you have log analyzer which makes sure that it doesn't have any secrets logging. Your unit tests are there, your integration tests are there, whatever secrets or something important things you are storing into database, you need to make sure that it is encrypted. It is either going to vault or database, wherever it is going, it has to be securely stored. Okay, so that is the code level security. Next security is at container level. Now container level security, it is again, once your Docker image is ready, you need to make sure that you are executing. There are tools available again to make sure that all vulnerability and different third party scans are done on your Docker image, so that no vulnerability. You must have heard a lot of vulnerabilities found in nowadays, right, in any library. So they release a newer version. So you need to make sure that you are on that latest version so that your code does not have that vulnerability. So that particular things you can implement at security at container level. One more thing, why people are preferring service mesh is because it gives your container level security. It creates a proxy above your container so that your container gets all the requests which are authenticated and authorized. Okay, so that's why people prefer to implement service mesh in their cluster. Uh, and the last is cluster level security that comes with your architecture design. If you use API gateway, then your complete cluster is protected by API gateway. Whatever request comes to your API gateway are always authorized first, and then it goes to your actual service. So your actual service is not loaded with any junk task. For example, if someone is trying to make your service occupy with thousands of requests, all the requests will directly go to API gateway and API gateway will reject them. Okay, or you can also implement API gateway rate limit so that someone cannot execute more than 100 requests at a time, or at us in a given second. So your service will always stay secure, your complete cluster will stay secure. So there are multiple level of security you need to implement when you are writing this microservices. Okay, again, there are static code analysis tools available. SonarCube is very famous for code level static code analysis. There are again tools, as I said, for container level security. You need to follow the best practices of Docker image. So all the communication of your microservices or outside the world will be using HTTPS. You can also make sure that all the requests pass through each service. If you have observed the OpenStack internal architecture, it gives all the time it keeps authority token. So for example, when one service is calling another service, it will pass that authorization token, and once that token is authorized, then and only then it will execute the given request. Okay, so basically it makes sure that no unauthorized calls are coming, even if it is from other microservice. So you can definitely implement all this level of security. Okay, then these are some design patterns I'd like to discuss. One is API gateway. API gateway, as I discussed, it plays a very vital role. It is a security guard for your cluster. It doesn't allow any uh, service to your cluster if it is not valid. Then aggregated design pattern we already discussed. Again, if you are implementing making your order service as a workflow service, it just makes call to two different service, and whatever response is there, it will assemble the response and provide a response to another service. And this is again the chain of service, chain of responsibility. Each service has their own responsibility and passes through masses. So one more thing, when you are designing chain of responsibility, most of the time what happens is request received by service 1 is not same as request received by service 2, because uh, this particular service is making call to this service in order to complete the given task of service 1 and not the actual service. So request gets modified by service. So there are multiple design patterns available. Service breaker design pattern is there, event sourcing, log aggregator, all these design patterns are there. You can make use of this design patterns while designing for your cluster. Okay, there are ample of advantages of using microservices. Scalability, one, which we discussed on the right monolithic architecture. That, for example, if your catalog service is loaded, then in earlier case we used to replicate the complete VM, which was doubling our cost. In our case, in this microservice case, what will happen? Only that uh, catalog service will be replicated, so there will be no additional cost. You will save a lot of cost. There is a huge flexibility, as we saw, right? Each this microservice are written using different programming languages, right? So there is no restriction. Your team can utilize the advantage of different programming language, like your front end is designed using React or Angular, your backend has multiple programming languages there, right? So there is a huge flexibility, agility, resilience. Your cluster is always resilient because you have multiple replicas of each service available. Okay, so for example, when I'm talking about a catalog, catalog already has three replicas available. Okay, by default. In best practices, we most of the follow that each service has multiple replicas available so that service doesn't go down. On top of it, in monolithic architecture, they used to call each of the application as a module, right? So for example, signature of any method changes, they will have a huge code dependency, and the other service will have to adapt it immediately. Over here, what happens in microservice, we have versions of API available. So my version 1 of API will have some different signature as per the earlier contract, and when I want upgrade in that particular API, then I'll create another version, that is version 2 of that API, and other services will not have dependency to upgrade that API immediately. Okay, one more advantage of using microservices will be, for example, there is a critical vulnerability resolved in any library. Okay, and that particular library is used by payment service, only payment service will upgrade, other services will always stay as it is. Okay, continuous delivery, team anatomy, autonomy, there are ample of advantages. The one of the best advantage which I observed was simplified debugging. Okay, in case of monolithic, it was becoming very difficult to identify what is the issue with my service, right? In this case, you will have your own service, and for that particular service you will have your log, you can directly extract your log and directly uh, identify what exactly is the issue. Okay, and improve time to market, as we discussed right earlier, it was taking about at least a month, and right now you will see Amazon and Facebook and all those are releasing new features every day, not even a day. There are big players who are releasing every hour. For example, Azure releases new services every hour. If you observe their release log, they keep releasing new features. Okay, so this and lower cost, so you save a lot of money, okay, by implementing microservice. uh, Other challenges are easy with microservice. One is while designing the uh, a contract of two services. So for example, catalog and orders will have to make sure that they know each other's contract, and the contracts are implemented as per the design. If there are any differences in that contract, or in any dispute while designing that particular contract, it will become very much difficult when it actually gets integrated. Okay, because every services are getting developed in their isolation, and they are connecting to each other using the predefined contracts. So they will have to make sure that contract doesn't get changed frequently. If it gets changed frequently, it will be a nightmare. Okay. Other challenges are there. I mean, infrastructure. So for example, we had at least four infrastructure available at different development level. One was for automation, one was for manual testing, one was for development. There was another was for resiliency test. So you have to have multiple infrastructure for each type of test, but the advantage you are getting is much more bigger than this challenges. But yeah, these are mostly design challenges, and testing challenges is, as I said, right, there are multiple level of tests. So you need to make sure that whatever you are making changes in your code have to be replicated in all automation tests. So that's also a challenge. And one more challenge is API documentation. So you have to have your Swagger documentations always up to date, so that anyone can easily identify and understand what your service is doing. Okay, what are the inputs and outputs and all. Okay, so these are some challenges, but there are many more advantages. So we can just skip those challenges. Okay, uh, and let's do the most fun part, the chat gpt one. I actually spent a lot of time for that. So chat gpt is a buzzword, right? Since it got released in November, everyone is moving towards chat gpt. So what I thought was, let's utilize the capability of chat gpt to make our life easy. Okay, so this is the landing page of ChatGPT, and I believe most of you have observed or saw this particular page. So, for example, I am creating a microservice for orders. Okay, so now when talking to ChatGPT, it is a machine. Okay, it gives you response based on your request. Okay, it doesn't do much funny things on its own. So that's why you need to be aware of the nomenclature of what you are requesting. Okay, let's try one thing. So for example, create a microservice uh, or orders. We'll go with orders. uh, it uses MongoDB for storage. Create net should be using this framework and this framework. Oh, yes. Yes. Okay. Also create its Docker file. Okay. So I'm requesting it to create a microservice on behalf of me. Okay. It will be using my MongoDB for storage. Okay, and it will also write unit tests for whatever code I have written. It will create, and it will be using Node.js and Express framework. And I also want Docker file for the same. So let's see. It will take some time. So it can help you, do all your boilerplate code. Okay, easily. So yeah, let's see. So it is writing UTs for methods it has created. This is for get post. Okay, so this is what happens sometimes. When the response is huge, it stops somewhere. So you need to say continue response, and it will start writing again. It has used a child framework, so yeah, put delete and Docker file. Okay. So you see, it makes our life so easy, and okay. So as I requested, it has given me response and created my this code using Express framework. Okay, and it is using MongoDB. It is using localhost. Okay, and if we check database, okay, it forgot to create something. Okay, uh, yeah, this is the stuff. Fine. So this is one of the service. If let's try to create another microservice, create the microservice for catalog. write it using Python Flask framework, generate unit tests for the same, and use gRPC for creating its methods. It should have go. Okay, let it create MongoDB collection on its own. Okay, so and its Docker file. So it will create another microservice for catalog using Python, Flask, and gRPC. This is the definition of RPC. So here we go. So it has by default taken ID, product name of the product, and price for catalog. Okay, it again stuck. It happens quite frequently nowadays because there are huge there is a huge overload to them. So need not to worry about it. But yeah, this is the overall idea that if you are aware of the nomenclature that in your microservice you need unit test, you need to generate Docker file. You can also ask it to create a Kubernetes file for you. It does all the things. Okay, once it is done, it's you who will need to take that code, update that code according to your requirement, and make sure you verify it well before pushing it. Okay, we'll also try to do some modifications. The beauty of ChatGPT, it retains the context. Okay, what that means is, okay, over here define catalog. Okay, it has used ID, name, and price. Okay, so what I will say, get above ones and build stock quantity. So earlier it was ID, product, and what was the price, I believe, right? So yeah, ID, name, and price. So it will also add a attribute uh, quantity. Let's see what it responds. See, it added a additional field for quantity, and it will also update the complete code base. Okay, so before requesting anything to this chat gpt, it is an intelligent framework. It gives answer to your question, but you need to make sure that it has proper input in order to make sure that you get the best result out of it. It also doesn't have logger, so if I ask it, it will also add proper loggers to it. And if you even see the Google code base, they also have maintained a very good level of logging. If I open any source, add a service, and a service is written in Java. So okay, add a service for Java, and you see logger was right away the first line. They have defined a logger and they have used that logger for further proper logging. And one of the best practice while writing a code in microservice, that you have a first logging line, that okay, we are performing this task right now, this is the entry point. Okay, it is a get adds, it is actually getting adds. So when getting adds, it first need to log that okay, I am getting adds. And another best practice is at the end you write what you actually did. And in case of catch, this is the same as the monolithic architecture. Okay, But in order to make sure that there is no communication gap, you should have this logs. Okay, it's stuck again. Can you response? Okay, so it will continue and will complete the response over here. So that's all I actually wanted to discuss during this session, and especially ChatGPT, because a lot of people are curious about how exactly we can utilize the functionality of ChatGPT to overcome our burden of daily tasks. So you need to make sure that you have proper vocabulary available when before talking to or before utilizing that platform. These are some references I searched and found quite helpful. So uh, yeah, you can refer these references. And just to conclude, microservice can definitely is a need of market. That is one thing, but it can simplify your life. It can give a proper visibility to you as well as an engineer, and that when my product is deployed, how it is utilized by customer, because you have access to those cluster, you have access to those logs, and you get immediate response. Like, just I said, right, if I am making any code change to my code, it will go to customer within 1 week. Okay. And yeah, it's a great fun working with microservices. That's all. Yeah, you see, the response is already there, and it also actually gives all the steps to configure your project. So you see the starting, it should have that init and all. It actually inits a project for you. Okay. Yeah, Soumya, I guess that's it from my side. Anyone has any question or would like to discuss anything? Uh, yeah, please raise your
Uh,
hand. Yeah.
yeah, if anybody wants to ask any question, please write in chat.
Uh, Trainer's screenshot. Okay, secret code. Okay, okay.
Yeah, for downloading the certificate.
Okay, okay. Design patterns deep dive. Definitely, I'll plan a session on design patterns.
Any question, guys? Please ask.
Thank you, Praful.
Okay. Thanks, Sanket, for a great
Yeah,
session, and thanks to everyone who joined. You can use the code that I've already shared in chat for downloading the certificate. It might take a few days to get it once we upload the recording of the session. We hope you all enjoyed the session. Thank you so much again, and have a good weekend all.
yeah. Thank you, everyone.